Now, as a second step of our question, in the second part, we will try to establish a connection between x bar, which is the sample mean, with mu, which is population mean. So first we need to draw samples of size n equals to 2. Draw all possible samples of size n equals to 2, and the technique that we are following is without replacement. Now how can we differentiate between sampling with replacement and without replacement? Let's consider that these five numbers we have written down on slips. We put it in a jar. We draw two slips at random. So let's assume that the first slip we have drawn and we noted down the number and we do not put it back to the lot, then it does indicate that it is the sampling without replacement. But if we put it back to the lot after drawing the first slip, then we call it sampling with replacement. In case of sampling without replacement, the first number that we have drawn already cannot occur again. So following this way, what I'm doing, again I'm writing down the values that we have taken in the population as 80, 82, 85, 88, and 90. Now the list of the samples that we draw starts with 80, 80 with 82, 80 with 85, 80 with 88, 80 with 90. We have completed the list starting with 80. Now we move to the next number 82. That's 82 with 85, 82 with 88, 82 with 90. Then we again move to the next number 85, 85 with 88, 85 with 90, and 88 with 90. These are the number of samples that we have drawn following sampling without replacement technique. These are in fact the samples. Okay, so 10 samples we have drawn, and we can connect the number of samples with the formula of combination that we use in probability. So over there we use the formula NCR to determine the number of possible combinations when we select R elements out of N available. We can synchronize this formula with our situation. We are doing what? We are drawing samples of size n, lowercase of n without replacement, out of the population size uppercase n. So that's 5 C2 gives us 10. Now in the next step, what we'll do, we'll draw, we'll compute the sample mean of each sample. So that's 80 plus 82 divided by 2 gives us 81. This would give us 82.5. This would give us 84. This would give us 85 as a mean value. This would give us 83.5. This would give us 85. This would give us 86. This would give us 86.5. This sample would give us 87.5. And the last sample would give us 89 as the mean value. Now, if we try to transform this to a frequency distribution, then 81 has the mean value is occurring once, 82.5 once, 84 once, 85 twice. What I'm doing, I'm cancelling out the second 85 from the list and telling this 85 with two frequency. So 83.51, then 1, then 1, then 1, and then 1. And this is how what we are getting. We are getting the value as now we will transform this frequency distribution to the probability distribution using a concept of relative frequencies. Relative frequencies approximates probabilities. This is what we have discussed the concept already in the previous lecture video. So we can now transform each frequency to probability associated with x bar values. So zero point 0.1, no point 0.1, 1 divided by 10, no point 0.1, no point 0.1, 0.2, 0.1, no point 0.1, no point 0.1, no point 0.1, and no point 0.1. And this put what we get the sum of 1.